Hello everyone, welcome to Geeks for Geeks. My name is Saurabh Bansal. So today we are going to solve the problem of the day. So today's question is largest square formed in a matrix. So let's understand the question, then we will find the approach of the question and then we will code the question. Okay, so we are at our computer screen. So now you can see over here. So the question name is largest square formed in a matrix. So they have given us a binary matrix, and now what is a binary matrix? A matrix which is having one and only zeros. Okay, so if a matrix is having only the numbers 0 and 1, it is called a binary matrix. So we have to find the largest square formed in a matrix. So please keep in mind that we have to find the square. Okay, now let's understand more about the question. So now we have to find the largest square formed in the matrix by ones. Okay, so this can be understood like this. So this is a matrix. So what is the length of this matrix is 1. Okay, so now you can see over here, this is also a matrix of length 1. This is also a matrix of length 1. You can see over here that here these ones are forming one more square that is of 1 and its length is 2. So 2 length. And now you can see over here that we have got one length, we have got one length. But now you can see over here that we have also a square that is of 3 length. Okay, we have 3 length, and now we have a 2 square length square as well over here. Okay, so we have to find the largest square. Okay, what is the largest square? Is 3. Okay, so we have to find the square with the largest side. Okay, so I think the question is very clear to everyone. Okay, now what is going to be the approach? Okay, so what is going to be the approach? The approach is very simple. We are going to use dp over here. So firstly, what I will do over here is, so I will make a array. Okay, basically the array is called dp array and it is having the size same as they have given a matrix. Okay, so let me just put the basically the index is 0 1 2 3 4 5 and 0 1 2 3 4 and 5, and let's put the indexes over here as well. 0 1 2 3 4 5, 0 1 2 3 4 and 5. So I have made an empty matrix like this. Okay, so now you can see over here that what you have to do is, so what is going to be the approach? So we have just firstly we will made a dp array. Okay, now in the dp array, what is going to be the approach is that, okay, at this point, we are going to store a number. Okay, please listen to me very carefully, that at a point of this matrix we are going to store the largest matrix formed as a left corner. So if I assume this to be a left corner, that largest matrix I can form from this corner. Okay, so this is going to be our answer. So let's just understand it more clearly. So what is going to be the matrix if this is the leftmost corner? So this depends on this corner. Okay, so maybe, so if I'm at this corner, so only one square, only one, if one length of square can be made over here. If it is a 1, then we have to put a 1. If it is a 1, because it can't form a 2 or maybe 3 or something like this, because it will come out of this box. Okay, so at the last row and last column you have to put the same values whichever is in our original matrix. Okay, because you can see over here only one size. If it is a 1, then only one size matrix can be formed from here. Okay, now let's talk about, so this is the simple problem. So we have to firstly put a cases for if the row is the last row. Let's assume the length of the rows equals to n. If I just assume row equals to n and column equals to m, then if row equals to n minus 1, then we have to put the same value, and for the column as well, if c equals to m minus 1. For both these cases I'm putting a or over here. Okay, so for both of the cases we have to put dp of I and j, dp of I as j as matrix of I and j. Okay, so there is a little space, so that's why I'm mentioning it like here. Okay, so basically this is one condition, this is one condition, and there is a or operator over here. So basically first is this. Okay, now so if if it is here a 0, if it is a 0 over here, so what you have to do? So if it is a 0, then you can assume that 0 cannot be the point of a square. So if it is a 0, then we have to put a 0. So there is one more condition, so let me write a condition more clearly. If r equals to n minus 1, that is a last row, or column equals to m minus 1. Okay, and also if and also I'm putting a or over here. Okay, let's remove this and then put a or. If or dp, sorry, if matrix, okay, this is a matrix, so basically in the question it is given, the matrix is given as mat, okay, mat, and mat of I and j, or maybe you can assume r or c equals to 0, then we have to put the same value as we have in this array. So basically the dp of ij would come like mat of I and j. Okay, so this is going to be the our approach, or maybe you can assume that r and c or I or j. Okay, and now for this part, what is going to be the value of this point? Now we have to take the minimum of these 3 points. Okay, firstly we have to make these 3 points. Okay, so as this is not the value is not present here, so we will start from here. Okay, so if it is a 1, okay, if it is a 1, then what you have to put over here. Okay, let's just remove this. Okay, so we have to take the minimum of this part, minimum of these three values. So what is the minimum of these three values? This is 1, and we have to add one more value to it. Okay, you have to add one more value. So minimum of these three is 1, and we have to add one more. So the minimum is 2. So now from here what you can get is that it is the point from where a two size square is formed. You can see over here. Okay, so two size matrix can be formed here. That's why we have stored 2. Okay, now it is a 0. So if it is a 0, then we have to put 0. If it is a 1, then if it is a 1, what you have to do? We have to find the minimum of these three values. The minimum of these three values is 0, and we have to add one more. So it is going to be 1. Now we have one more, this value. What is going to be the answer of this value? Minimum of these three values, that is 0, and we have to add 1. Okay. Now this is how we will fill this array. Okay. If it is a 0, then we have to put 0. Now this. Okay. So we have to find the minimum. Minimum is 0 and plus 1, that is going to be 1. Okay, we have to find the minimum is 0, now 1. You can see over here that if it is the leftmost point of the square, then it can only form a one size matrix, because one size square, because here is a 0. That's why. That's so I think the approach is might be very clear. Okay, let's do one more time. Okay, if it is a 1, then you can see over here we have to find the minimum of this. What is the minimum? 1. We have to add one more, 2. Okay, you can see over here that a two size square can be made at, if this is a leftmost point, then two size square can be made from this point. Okay, so you can see over here. Okay, minimum of these three values, it is 0 plus 1, that is 1. Okay, so this is going to be the approach. So let's code this approach and then we will find the other things. Okay, so firstly what you have to do is, firstly let's just make an array of this. So I will make a dp matrix equals to new int, and the sizes are given as n and m. So I will put the same sizes like this. Okay, now what you have to do is, let's just write a loop. Int I equals to n minus 1. So I will start it from last and take it towards the 0. I minus minus. Okay, and for this part, for int j equals to m minus 1, j greater than equals to 0, and we have to put j minus minus. And then we have already discussed about the situations. So if I equals to n minus 1, that is the case for the last row, or j equals to m minus 1. So these row are going to get the value as dp of ij is going to have the value of matrix of ij. Okay, so these are the cases. Else if matrix of I and j, if it is equals to 0, then we have to also do the same work. dp of I and j is going to have the value of matrix of I and. Now in the else condition, what you have to do? So we have to find the minimum of these three values. Okay, we have to find the minimum of these three values and going to put in the dp value. Also let's discuss about the answer as well. So basically the answer is going to be 3. Okay, basically we have to find the maximum value of this dp array. Okay, so the maximum value of this dp array is going to our answer. Okay, so maybe I think there the 3 will come over here, and we have to find the maximum value of this array. So I will also initialize a variable that is called int answer, and I will initialize it with 0. Then else if these are not the condition, then what you have to do? Then firstly dp of ij is going to have 1 plus of minimum of the three values. Okay, so we have to find the math dot min. I'm using this formula, math dot min dp of. So basically firstly I will put the diagonal part, that is called dp of I plus 1 and then j plus 1, and after this I will find the minimum of the other two vertical and horizontal values. Okay, that is going to dp I plus 1 and j, and then dp of I and j plus 1. Okay, so this is how we will put the values, and we will find the minimum, and after the cells we will update the answer value as well. Answer of mat.max, so we have to find the maximum value, that's why I'm putting this. Answer equals to mat.max of answer comma dp of ij, dp of I and j. So this line will find out the maximum value of this whole dp array, and now we have to return the answer. So this is how we are doing this question. So let's try to run this. Okay, so I think there might be some error. Okay, tp of I plus 1 j plus 1 mat dot I. Okay, so I forgot to put the tp over here, so it is giving us right answer. Let's try to submit it. Okay, so we have submitted the question. If you like the video, you can share it with your friends. Thank you everyone. Bye.